So here we need to come up with the maximum and the minimum possible value of the overlap. So if we look at Venn diagrams in general, that's the overlap, meaning people who drink or like coffee, tea, and lemonade. So we need to maximize and minimize. So maximizing, we can think conceptually, is that if everyone that likes lemonade is part of that people who like coffee, so something like that. So coffee is 73, that's lemonade, which is 52. And then we enclose this within the tea, which is the 80. And that way, this would be the overlap between all three. And then the number who don't like any of these three drinks, because the total is 100, that just needs to be 20. So as we can see, the maximum, we're kind of thinking in terms of extremes, maximum is 52. So we know max is 52. The question is, what's the least? And I think that's the hard part here. And I'll have to kind of set up the equation. And at least this is kind of how I know how to do this question. Maybe there's easier way to do it. So our categories are 73, 80, and then this is 52. And let me say this is Y, A, B, and C. So A is this region only. So whenever I label these, that represents only those regions. Y would be students who like all three drinks. And then outside this box, we have students who do not like any of these three drinks. So the condition is that all of these have to add up to 100. And the way I do this is this whole circle is 73. Now I need to add this portion here, which would be 80 minus B minus Y minus C. This is really just the triple Venn diagram formula. Some of you might remember. You can apply that directly. And then this category here would be 52 minus these three pieces. So 52 minus A minus C plus Z, which is the ones who do not like. So that has to be, this is the triple Venn diagram equation, really. So these three I can add up, and that would be 153. So that's 205. And then I'll have Y minus 2Y. So I usually strike these out as I'm adding them. And then I have, I forgot to add this piece, C, as well, because we were adding that piece, which was this. So make sure you kind of do this on your own as well to see. And then that piece here. And then I have to add that piece. And this remaining, this circle was 73. And that was this piece here. So I need to add a C here. And you'll see these two drop out. So I get minus 2Y minus A minus B minus C. So you have this, this, this. And I've done this before, so I kind of know what to expect. So this is what we end up with. This is 105. I'm interested in Y, so I move that to the other side. I get 2Y is 105 minus A minus B minus C plus C. Now, what are the constraints on A, B, and C? So we have three constraints. A plus B plus Y, meaning these three regions here have to be less than 73. Same thing, A plus Y plus C has to be less than 52. I'm just kind of, that's the upper limit for all three. I know it's getting a little bit messy here. And B plus Y plus C has to be less than 80. So if I add these three inequalities, I end up with 3Y plus 2A, do A plus B plus C less than, and this is 205. So from this, I'm going to isolate A plus B plus C. I'll move it to this side. Becomes 105 plus Z minus 2Y. And I'm going to plug that in here to see what constraint do I get on Y. Less than 205. Then 3Y plus 2, sorry, this would be 210 plus 2Z minus 4Y less than 205. That becomes 0. That becomes 5. This becomes minus y, and I'll move that to the other side. So y becomes greater than 5 plus 2z. So you can see the least value of y has to be 5. Z can be 0. So my least value is 5. Maximum is 52. We're looking for the difference, which is 52 minus 5 is 47, which is choice C. So this is kind of how I did it. Maybe there's a way to do it conceptually, just like I did the maximum part. I don't know how to do that right now, but I have a suspicion that there is a cleaner way to kind of think about this question. So I'll kind of come back to this question if that sort of thought comes to my mind. But for now, the answer is C.